All right, well, this is probably the highlight for a lot of the students. We've done a whole bunch of 2D CAD up to this point, and you've drawn a bunch of stuff, and I'm not going to lie to you, um, there's not really a lot of opportunity for creative expression in a technical drawing class. A lot of the times I need to see that you know how to use the tools correctly, so to do that I have you draw specific things at specific sizes, and you don't have a lot of leeway to mess around or design stuff. This assignment is going to change that completely because you're going to have freedom to design something that you want. And you'll also have the chance to use some cool digital fabrication tools. So let's go on and have our discussion. We have already talked about CAD, Computer Aided Drafting, and you know what that stands for. You've seen it many times. Now let's talk about CAM. And CAM is short for Computer Aided Manufacturing. So basically using a computer to drive a tool to create a cut path or to form. Computer-aided manufacturing incorporates a lot of different technologies. Water jet is one of them. Plasma cutters is another. And of course laser cutters. So if you haven't seen any of these things ever work, let's just take a quick look. A water jet cutter takes water and pumps it at 80,000 psi through a very small nozzle and adds a little garnet to the water to make a slurry, and that bowling ball is being cut in half by water. That's a pretty powerful cutting tool, and you know the only thing they needed to cut that was a single simple CAD drawing, a line with that little notch, and the machine does the rest. Doesn't have to be some fancy 3D model, and when we're all done, we've got our bowling ball cut in half using water pressure. Pretty slick though, huh? This is another one of these cutting tools that uses CAD drawings as the basis for what it's going to do. It's a plasma cutter. Plasma cutters will punch through metal using a plasma field generated by electricity, and you can cut out any shape, any sizes. You can be very creative with a plasma cutter. And again, it's the computer that is driving the cutter and telling it where to cut, when to cut, and computers don't make mistakes like humans do when they use handheld plasma cutters. Right, so that's cutting at a speed much higher than a person could do it, and with way more accuracy than a person could do it either. And of course, this was all drawn out in CAD prior to sending it to the machine. Working with cabinetry, there are CNC tools that do cutting. This is a CNC Panel Router, and the panel router cuts the different parts of the cabinet so that you don't have to cut the stuff on a table saw, which is pretty cool. So that panel router goes over to the gantry, it picks up the correct cutter, correct size it needs, and it plunges into the material, and then it drives itself in the XY axis, and it'll do cutting. It'll also do drilling. It can bore a bunch of holes for adjustable shelves. There's all sorts of things that you can make on the panel router that save you from having to buy other equipment or use other equipment that would do it a lot more slowly and maybe not with the level of accuracy that you would want. So this is a panel router. And of course, laser cutting. Lasers have become ubiquitous at educational institutions. If you could draw this gear profile in CAD in about 2 minutes, you could take it over to a laser and then have the laser cut out the pattern. Because I'll tell you what, cutting that out with a coping saw and then going in, trying to clean it up with a rasp, that is not fun right there. That'd be an awful lot of work. So once upon a time, we talked about what can you draw in AutoCAD, right? But it wasn't just draw, it was make. What can you make with AutoCAD? And the fact is you can make a lot of stuff. There's a lot of computer-aided manufacturing equipment that relies on CAD drawings to generate shapes and geometry. Now, we've learned about raster graphics and vector graphics, and some of these tools use one and some use both. For example, our laser, we can work with raster graphics or vector graphics. And then the plasma cutter, that only uses the vector graphics. So having a knowledge of how to work with both is going to be really handy when it comes to you designing something that you want to make for yourself. So what kinds of things can we draw or create using a laser? Because that's the system we're going to be working with. We have a laser cutting system in the industrial drawing lab. What kinds of things are made on these kinds of tools? Well, things that require high levels of precision that would be murder to cut by hand. So this map, this is a bathymetric chart of the waters around Nantucket Island on the east coast off of Massachusetts. This is pretty cool, right? So someone went online and found some map data, USGS probably, and they imported it into the CAD program. They've got all the contours they need. They got some thin plywood, and they did their cutting. And believe it or not, these things sell online for like $400 and $500. So there are people out there that have a lot more money than sense, and they'll pay big bucks for cool stuff like this. So if you're a crafty sort of person, or a maker, or a designer, you got some ideas. If you're an entrepreneur, getting involved in laser work with your CAD background now is a natural fit. This is a map, street map of Manhattan with all the bridges connecting it to the surrounding land of New York and New Jersey. Right, so what are we looking at? Well, we're looking at a bunch of lines, right? Cut out of some black mat board perhaps, and put on a piece of white mat board. And again, you know, you've got a $200, $300 wall hanging here, and the laser did all the hard work. The person didn't do anything, except maybe, you know, snap it into the frame. Anything that can be drawn can be cut out. So here someone wanted to work with the states, come up with a design. You could cut out solid wood, not just mat board. This little puzzle is the African nations, all fit together out of different kinds of wood. Very artistic. You can make maps out of places that don't even exist, right? This little Ferris wheel here, can you imagine trying to cut this stuff by hand with a handsaw and getting it all fit together? It would be absolute murder. And yet with a laser, we could draw the parts out in CAD and quickly cut this out and have it assembled, and it's flawless. Simple things can be cut out and embellished with CAD drawings. Leather can be engraved. So this brown leather notebook was engraved with some raster graphics of brambles and tree leaves and this crow, and customized. So that's another kind of cool thing, not just cutting things, but engraving. Here's some cutting projects. We've all seen stuff like this at the Natural History Museum, right? These are thin pieces of plywood, laser cut, and then fitted together. And then, of course, in the signage business, laser cutting, vinyl cutting, it's all the same. It's all pretty big. Black acrylic on white acrylic, each letter cut out individually and glued on. This is some expensive sign work. Here is a photo that's been laser engraved, laser etched onto a piece of acrylic. And then as the light passes through the edge, it kind of illuminates the photo, which is kind of cool. If you're an architecture student, I can't even imagine trying to make this model at this scale. Now this model fits in my hand. Look at how tiny all these different elements are. See, this would be impossible to make using traditional modeling tools like an X-Acto knife or a razor blade. It's just too small and delicate, but the laser can easily pull that stuff off. We can even take flat stuff like plywood and make it bend. We can throw some curves on it, and here we have some corners that bend around these radius edges here. Here's another one like that. And then even just simple stuff, you know. Someone wanted to make something to hold their earbuds. Here's this cool little skull-looking thing with its tongue sticking out, I guess, and his googly eyes for the earbuds. Okay, we can work with wood, we can work with acrylic, we can work with plywood. There's a lot of different materials you can work with. Acrylic has the advantage of also lighting up when LEDs are projected onto it. So Bender here is glowing because there's a little LED strip underneath that piece of acrylic lighting them up. Here we have some fancy maps, laser cut and created. A little wine butler there to hold wine glasses. And, you know, if you're a woodworker, you can easily make stuff like that. But if you're not a woodworker, what if you've never taken a wood class? What if you've never taken a machine shop class and you want to make things? You know, you're kind of at a disadvantage. But having CAD tools and having digital fabrication tools like a laser really evens the playing field. This is made of a bunch of different layers, registrations through the model. little porky pig. Here we've got a puzzle made out of the periodic table, so engraved letters on a piece of plywood, and then the individual pieces cut out. I'm sure that there's a happy deer out there somewhere since his head's not hanging on the wall, but again, these are just individual slices of plywood that have been laser cut and laminated into the figure. United States with rivers, kind of cool. Here's a very fancy, probably another $200 or $300 wall hanging, laser engraved piece of maple it looks like, with the river system for Lake of the Ozarks cut into it. And then if you are detail focused and you are artistic, wow, there's all kinds of things you can make with a laser that would be so near impossible to do by hand otherwise. Okay, so this is inspiration. This is supposed to give you some ideas. You could take images like the Aztec calendar, and without really doing much, you could take that raster image and engrave that onto a piece of wood, and you've got the engraved calendar with very little work. This cube, laser engraved on the exterior, each of the faces. Looks fancy, right? And here's some more signage with some thick material, thick acrylic. Some more thick acrylic laser cutting for signage. Here's some plasma cutting, but same idea. The letters are cut out, the logo here is cut out, and it's applied to that lighter piece of steel underneath. So lots of things that we can do with laser and laser cutting, or related technologies like plasma and water jet. Incidentally, BC has all three. We have lasers, we have two of them, one in the industrial drawing lab and one in the wood shop. We have a plasma cutter in the welding lab, and we have a water jet machine in the engineering materials lab. So we're going to practice how can we do a little bit of laser cutting and laser engraving using Autocad and using some of these images. So I found some superhero images online, but this will work with any image, your favorite football team, your favorite brand, your favorite sports, whatever, your favorite band, you can find anything you want, and you can turn that image into some vector graphics that we can cut and engrave. So to do this, we're going to work on this together, and this is our exercise. We're going to go over to AutoCAD. We're going to make a brand new clean shiny drawing from scratch. So start drawing. And then we're going to make a few layers to get this thing started. Alright, so our drawing set up, we can leave it in decimal units. We can leave the limits at 9 by 12. We're not going to go beyond that, but we're going to make some layers together. So first layer is called cut. Second layer is called score. Third layer is called engrave, 0.5. And these are three of our main layers we're going to use. Cut needs to be red number 1. And cut also needs to be 0 line weight. Score. A scored line looks like it's made by a razor blade. It's very thin, very precise. So the score needs to be blue number 5, and it also needs to be 0 for line weight. Now, cutting cuts through the material completely. Scoring is like a razor thin line, very precise and accurate. Engraving is more like wood burning. So engraving is going to be for heavier lines that we want to burn in dark. So this color stays white, and then the line weight will be whatever line weight we want to work with. So I'm going to set it for 0.5 because I call this engrave 0.5. You can actually make as many different engraved layers as you want with as many different thicknesses of line that you want for line weight, depending on what you're doing. I would just suggest making a different layer for each line weight so they're easily adjusted or fixed later on if you need to. Now I'm going to add 2 more layers. I'm going to add a layer for pictures. So we're going to go get a picture off the internet, and we are going to use that as the basis for our drawing. I'm going to make it yellow, and we'll make it default. And then finally, last one is called trace. And trace needs to stand out. So I'm going to pick the worst color ever, magenta, number 6. And I'm going to make it very heavy, 0.5. Maybe 0.7, even heavier. Okay, so I want a very dark, bold line. Okay, so cut, score, engrave, 0.5, pictures, and trace. So that's step 1. Step 2 is let's go over to Google and let's go find something we want to trace. So you can find anything you want. Okay, any image you want, any graphic you want. Obviously, the simpler the better. You know, a family portrait is not going to work, but I'm going to go here with Superman. Superman's a good guy, and I like the Superman shield, and I would like to do some laser cutting and laser engraving. And I got sucked into SD here, huh? Okay. So when you get the image you want, what you want to do is you want to save the image. So most people know how to do that. I'm going to right click on the image and go save image as, and then go save that in your B12 folder, in your assignment folder. So you know where to find it. And then what we're going to do is we're going to go to the picture layer and we're going to attach that raster image. Right, so there's Superman, and I say open and OK and attach. Okay, so image is in the background, right? Next step, we're going to go to the layer called trace. So what I want to do is I want to use the image as the basis to trace some vector lines. So trace is a very heavy line. Make sure your line weight's on. Trace is also magenta, which will stand out against pretty much everything. If you got a white line and you're trying to trace white lines on top of white, good luck trying to see them. But magenta will be very easy. So I'll go to line, and where there are straight lines in my drawing, I will draw straight lines. And who knows, maybe even some of the angles will work out and line up, right? But I'm basically going to use move, zoom, pan to get my way around. Don't know how I just did that. That's exciting. And then complete the outside shape. Okay, because that was made with all straight lines. Now, there are other parts of this drawing composed of straight lines. So if you have straight lines, draw straight lines. Okay, it looks like straight line there, and straight line here, and here, and even a straight line that goes up to there, through those parts. This guy looks like he goes through here too. Okay, so straight lines might take care of some of your design. Now there'll be other parts that you need to use the arc tool. Start point, midpoint, end point. Start point, midpoint, end point. Right, and that's going to create that 3-point arc for you. Start point, midpoint, and I'll say give me nearest for my endpoint. Okay, so where you can use lines, where you need to use arcs, use the 3-point arc. The snap to nearest is kind of nice when you're doing stuff like this because we're not trying to be accurate so much. We're not looking for the tangencies and the perpendicularity like we were when we were doing a technical drawing. This is more like graphic arts, right? Okay. Lines, arcs, and then probably the last one you want to use is spline for the things that are just non-circular. So like starting here and going to here and going to here, I can work through the S to get those curves. Of course, every time I click with the spline, it's leaving behind a control point that later on I can go back to, so I can adjust it if I'm not happy with it. Okay. So I'm going to go through the design and finish up the rest of the line work. All right, so it looks like I've got all my line work done. Pretty happy with it. Now, the reason you put the picture on its own layer is because you want to turn it off when we're all done. See, so what I'm left with is I'm left with the raster turned off, and I'm left with vector graphics, which is what I'm interested in having. All right, fillet U here to here. Looks like I might have to do a little bit of trimming. Let's see, oh yeah, because I'm not totally familiar with Superman. Let's get him all cleaned up here. Oh, you go away, you go away, you go away. And I need a little line segment there. There we go. Okay, much better. So we'll turn off the picture layer, and I see now I have my S for the Superman shield. Now I need to start making some decisions on what am I going to do? What's my next step? What am I intending on making? You know, I kind of envision this as a piece of acrylic that's cut out in the shape of the shield with some engraving on it. So trace is only the layer we use to trace things out. If you want to cut things out, you'll have to select the lines you want to cut, and you'll have to put them on the cut layer. And then for the other parts, if you want them to score, which is a very thin, precise line, and then you'll need to put them on the scoring layer. And then if you want to fill areas in so that they can be engraved, put the engraving geometry on the engraved layer. I think I'm going to go in and I'm going to get solid hatch. All right. And now what I've got is I've got a diamond shaped cutout, right? That pentagram. It's going to just be cut out on the outside edges. It's going to score a very precise line to make the outline of the big S. And then it's going to engrave the S. So on plywood, engraving is dark brown, and on acrylic, engraving is white. Acrylic is clear, you'll get a white engraving. Plywood is wood color, you'll get a brown engraving. Right, so this is one option. This is one option. There's a lot of stuff that we can do. Here's another option. Cut out the 5-sided polygon and then engrave a nice dark line for the outlines, and then maybe we put a hatch using the diagonal lines as a scored hatch to kind of shade it in. Okay, how about we just cut out all the elements? So this is one single piece of plywood or one single piece of acrylic when it's all done, right? And then you'd be able to see through the parts that are cut out. That's another option. Okay, or what if we did this? What if we made a circle? And then what if we made a smaller circle at the top? And then what if we took our line work and put it on engrave and then stuck it in there? Right, what are we going to get? Well, we're going to get a piece of wood or a piece of acrylic that is round. When it's all done, it'll have a hole in the top to maybe hang it from a nail or a tack in the wall. And then it's got your design engraved on the material. So there's a bazillion different options, different things you can do. The sky is really the limit, you know? So think about what you'd be interested in making that maybe is something that you have a connection to, something that is significant to you. And then what we're going to try to do is we're going to try to draw the lines out with vector graphics using lines, arcs, and splines, circles if necessary. We're going to assign those different elements to the correct layers so that we want things to cut, they will cut. We want things to engrave, they will engrave. And if we want things to score, they will score. Think also about what shape do you want the material to be cut out when it's all done. I showed you the circular one with the nail hole. We could have a rectangular. You can make an ellipse with the axis and ellipse command. You could just do some offsetting and copy the shape that's already there for whatever shape you're working with, right? And this will produce our graphics. You can use any of the commands we've used to draw things. You can use the array tools. You could use hatches. The sky's the limit, okay? When you're all done, got 2 requests for you. First request is to open up a modify panel here. There's a modify tool I want you to use on your finished drawing, and it's right here. It's the second to last one. It's called Overkill. And what that does is it will make sure that there are no lines on top of lines in the drawing. So overkill or delete duplicate objects. We'll just see if there's a line on top of another line. And if there is, it'll delete it. So start the command, select your geometry, hit enter. Just leave everything set to the default, hit OK. It found 13 duplicate objects and it got rid of them. And you know, that's kind of important. With a laser, a red line means cut. So what will happen is if there's a line on top of a line and it's 2 red lines, what it'll do is it'll cut once through the material and then it'll cut a second time. But now it's cutting my laser and I'm not too happy when that happens. Okay, so we use the overkill command when we're all finished. And then the second thing that we do is we're going to scale. Okay, so I want you to make me a rectangle that is 6. Hang on. Let's do this. Let's just hang on to our graphics when we're all done. Okay? And when your graphics are all finished, we'll see how we're going to use these to make something practical. So the assignment that goes along with our discussion on laser engraving and laser cutting is something I think you're going to find practical and kind of fun to make too. The instructions are here, B12 7D. This is our laser engraving and cutting project. And what you'll be doing is you're going to be making a phone stand. And we're using the laser to produce it. And basically here's what we get when we're done. We have 2 pieces of laser cut, either acrylic, clear acrylic, or plywood. And you'll have to make the 2 pieces of material, the sizes that are called out here. And then arrange them in your CAD file so they look like this. The one piece is here, the second piece is right next to it. And then in this area here, you're going to take your graphics that you designed, scale them down, and have them incorporated as part of the design of this. So if you're a big Game of Thrones fan, right, I've got the Stark Wolf here, traced it in Autocad, and I'm adding 3 of those, so when my phone is not on there, I've got something fancy to show off. And heck, you can put your name up there, you can do anything. You can do engraving on the one side, you can do engraving on the back side if you prefer the image on the back side. Alright, but the idea is this is a practical thing that you can easily break down and carry around with you. It's not glued or nailed together, it just slips together. Clicks, it's a snap fit, and when it's done you've got stuff that other people don't have, which is cool, right? Projects that other students have done, designs that I've seen some really crazy stuff. You know, we've got the football. This student didn't really like the idea of just rounded off and square corners, so that's fine. You don't have to have rounded off corners on a rectangle. She went in there and she made some hearts and then offset the hearts and cut out the spaces there. This has got a lot of floral tracery on it and some fancy script for the name. I've seen all kinds of cool designs incorporated into this project, which is kind of neat. A Dodgers fan, right? Cut the shapes out of the red and then have your engraving on the engrave layer. This one here, I have no idea what it is, but it's cool. It's very freaky. I like it. This one here, oh my gosh, levels of detail that you really got to get in there to see, but a lot of it was done with the array command, which makes things a lot easier. So the idea when we're done is we've got a product that you've designed, you've drawn it in CAD, we're going to cut it on a laser, and then you've got something unique. Now, if you're in my online class, you might be saying, well, how am I going to cut this thing on the laser? And the answer is, I'm going to cut on the laser. You're going to upload the file, you're going to submit it to me, and I am going to go into the lab and then cut it for you. What we'll do, since you have paid a lab fee, and really you're not really getting anything out of the class that students would get if they were on campus, you are going to get this mailed to you. All right, the two separate pieces, I'll put in an envelope. I will send it to your address as long as your address is correct in BandWeb, and you'll have your project shipped to you through USPS. Now, if you don't want your project, please tell me that. When you upload it, just make a little comment in the comment section that, hey, I don't want this. I just did it for the points, and that's fine. I get it, okay? But if you design something that you really like and you want it, then tell me, hey, I would like this, please. If you can go to the campus and cut me one, I'd appreciate that. And I will make sure it gets mailed to you, and you get a copy of that. Okay, so we've got our industrial laser. I'll be working with this. And for future reference, if you want to do laser cutting, since you have completed the CAD portion of the B12 class, you're basically ready to draw and cut things, as long as you supply the materials for them. And we can talk about what materials are acceptable sometime in the future. I have students that come back after the B12 class, and they use this thing all the time. I've got automation students that want to design different kinds of shrouds and enclosures for equipment. We've got students that are kind of entrepreneurial and have cool ideas. I have students that just don't want to spend money on Christmas presents or birthday presents, so they come and they make stuff on the laser, and that's fine too if you want to do that. As far as I'm concerned, the more CAD you do, the longer it will stick with you. And you can think of this as the carrot in front of the donkey. You're the donkey, this is the carrot. I want you to continue doing CAD, and by letting you use the laser, if that's what keeps you in, that's fine, okay? I will supervise and help you out and get you unjammed if you get stuck, but you'll have access to this machine from here on out, basically. If you have any questions about the laser, its use, other things that we can do with it, how to engrave a photograph, what kinds of photographs engrave best, a lot of this information we can talk about one-on-one. There's a lot of stuff in the course pack that's very helpful. So make sure you take a quick look and read through the information in the course pack on laser cutting and laser engraving. This might be something that you're going to do more of down the road, whether in this class or at some future semester when the semester is over. So this more or less rounds out our discussion on working with CAD files and using them alongside digital fabrication equipment like lasers and water jets and plasma cutters to produce cool things. If you have an entrepreneurial spirit, I gotta tell you, you can make a lot of dough with a laser. I have students who have gone out and they decide they're going to make a small investment. Well, not really a small investment. It's a couple $1,000. You can get a really good laser for about $2,000. This is actually a home workshop laser called the Glowforge. The laser that we use is a 65 watt CO2 laser, talking about $35,000. Not really affordable for most people unless you're intending on making some dough with it in a commercial setting. Got a former student named Dan, and Dan wanted to justify buying a plasma cutter to his wife. So Dan took my CAD class, and after a couple of CAD classes, he was quite the CAD expert. So you can see what he's doing here with his plasma cutter. He's making signs for his friends and his family and neighbors. He's making custom skateboards, and there's his plasma cutter back there. That's, I think, for a horse on the horse stall. I mean, pretty cool that you're able to make stuff like this with a machine that you drew the parts out. The machine does the cutting. This is a steampunk switched lamp. It's like a 70-pound desk lamp, but I mean, it's cool looking, right? And people like unique stuff. People like cool things. Football logo. This is about 3 feet tall, so he makes some big stuff on that plasma cutter, and they all start off as CAD drawings. And from there, the machine does the rest of the work. So even the simple stuff like a trailer hitch cover, you're able to do some amazingly awesome stuff with the CAD skills you have. And I'm hoping that having access to this equipment is going to keep you interested in doing some more CAD as the semester goes on, and even into next semester and beyond. This is the conclusion then of our discussion on laser cutting digital fabrication from CAD files.